Good evening, everyone. In this video, we will be talking about class design. The analysis phase, okay, mainly determines what the implementation must do. Okay, this we have seen in both the domain analysis and also like application analysis. Okay, so it determines like what the implementations must do, what the application must do in that sense. So then the analysis model actually describes the information that the system must contain and the high level operations that it must perform. Okay. Once we had seen the analysis model, then we talked about the system design. The system design actually, system design phases, during the system design phases, you actually determine the plan of attack. How do you attack a problem? What would be the performance of it and etc. We have discussed all those things in detail earlier videos. Now comes the class design. The purpose of the class design is to complete the definitions of the classes. See, during the analysis you found out the classes, and then the system design, like you determine like how to attack those classes, okay, and what are the external parameters, other parameters which actually affect, okay, the system architecture. And now during the class design you are actually trying to complete the definitions of the classes, okay, and all the associations, and you actually define the algorithms for the operations. By the time of the class design is ready, like you are ready for implementation. Okay, so all the design is complete, more or less. In terms of the class design is concerned, okay, so you will carry the analysis classes directly into the design. Whatever the classes which you have developed earlier during the analysis phase, okay, so both domain analysis and application analysis, these classes are directly carried into the design stage. And during the class design, you will be adding additional details and then like make a final decisions there. Okay, so in that sense, like we already talked, like there will be several iterations of this sort of analysis, design, and implementation. Basically, will be going on. Okay, so basically, like so it will be going in the iteration. Okay, so by doing this way, say for example, by carrying the analysis classes directly into the design and then like trying to improve them. Okay, both the analysis and design models will be consistent, okay, as they evolve through these sort of iterations. And during the design, like we have to choose like among different ways to realize the analysis classes. Okay, that is the main step of it. Okay, so that means like we have to focus towards minimizing the execution time. Okay, so minimizing the memory or other cost measures, etc. So we have to take care of all these things during the design stage. We may also have to flesh out the operations. Okay, so operations we have to basically clear them, clean them. Okay, and we may also have to choose the algorithms, of course. That's the main goal of it. Okay, and we may have to break these sort of complex operations into several simpler operations. Okay, so that's also the part of this class design. As I already mentioned, this decomposition again is an iterative process. Okay, so it is repeatedly, it is repeated successively for different lower levels of abstraction. Say, for example, you will have the operations at a higher level of abstraction. Okay, and then like you decompose them and you basically get them at lower levels of abstraction, and you keep on repeating these sort of iterations. Okay. In the process, like we may also have to introduce new classes to store these intermediate results. Say, for example, like during the program execution, okay, certain results you will be calculating. Okay, so these intermediate results you may store in certain classes as variables or something. Okay, for that, like you basically have to add new classes, etc. Primarily, you are avoiding recomputation. Okay, so these are some of the steps like which we should be looking at. These are some of the class design activities, more or less. Let's look at all the steps which are to be taken care in the class design, one after the other. And just like last time for this system design as well, we'll be discussing about each and every topic in detail in the coming videos. Okay. So in the steps for the class design is concerned, we first have to bridge the gap. So the first step is bridging the gap. So the gap is actually, say for example, what are the desired features like you want to achieve, and what are the available resources for you. You basically have to basically try to reduce the gap between that, and then like you are actually adding all this implementation, all these design details, okay, to basically bridge the gap. Then we have to realize the use cases. Okay, so that we'll be discussing. And then like we have to design the algorithms. What are the considerations we have to take in terms of designing these algorithms? We'll discuss them in detail. Okay, and then like we have to go recursing. We have to somehow like recurs downward. Okay, so decompose the methods to lower level of abstraction. Okay, we'll see this one in detail, but that is what I have been telling. So you will take a higher level of methods, and then like you will be basically decomposing them, okay, into lower levels of abstractions. Then the next step is refactoring. Okay, so refactoring basically deals with changing, making some changes to the internal structure of the software. Primary goal is to basically improve its design without altering the external functionality. External functionality will not be touching them. Okay, so but still like you would like to refactor them. Okay, we'll see these things in detail with examples. Then comes the step of design optimization. Okay, say for example, like whatever we have talked earlier. Say for example, saving the intermediate results to basically avoid recomputation. Okay, so that comes as part of this design optimization. Then the next step is about reification of behavior. Okay, so we already seen in the classes the reification. Reification is the promotion of something that is not an object into an object. Okay, even behavior actually fits into that one. Behavior means like say for example there is a method. Okay, so you have a business logic, which is generally rigid. But the thing is like if you want to save it and then like reuse it at different places. Okay, promote it to a class, promote it to an object. So reification of behavior, that's about it. Then we may also have to adjust the inheritance. Okay, say for example like earlier we were thinking about only some classes and then like its subclasses and everything. Now once you have say for example more or less all the designs, okay, so all the analysis classes are there and then like you started designing the things, you may have several classes and you may extract this common behavior out of a group of classes and you can have new levels of inheritance. Okay, so that is also a step in this class design. Then we also have to organize a class design. So basically like we have to organize all these source files, packages, etc. Okay, so all these things like we'll be discussing later. Okay, that's about the steps in terms of the class design is concerned. Okay, more or less in summary like what we are doing is like, okay, so we are taking the classes, okay, from both these sort of domain analysis and application analysis, and then like in the system design like we are actually chalking out like, okay, so what we would really like to do and then what are the performance considerations, etc. And then like by the time of you come to this class design like you are actually more or less making the classes ready so that like they can be directly implemented. Okay, so in terms of the reference is concerned, now we are starting with chapter 15 of object-oriented modeling and design with UML. So Michael Blaha and James Rumbach. Thank you very much for your attention.